Hello and welcome back. So now let's do a problem where we actually find the absolute maximum and absolute minimum of a function. So let's say we had the function, I'm going to call it f of x, equals x squared, and we were looking at this function on the interval from -2 to 1. I'm going to draw a graph of this function because I know what the graph of x squared looks like. So let me draw a graph really quick. So the graph of this function on this interval from -2 to 1 would look something like this. It would end right there because it wouldn't go on until 2. So let me actually write down the values. Let's say this right here is -2, it's -1, this is 0, and this is 1. So we're looking at this, and just by looking at this, we know that the lowest point is right here, and the highest point is right here. But they're not always going to be something that you can graph like x squared. Sometimes you'll get a funny function which you don't know how to graph. So let's use our knowledge of derivatives and calculus to figure this out. So step 1 to doing this problem is to find the critical points. Find critical points. And to find the critical points, within this, I'll call that A. To find the critical points, the first thing is we need to find the f prime of x. And so we use our knowledge of the power rule to find f prime of x, which equals 2x. So now that we know the derivative, step B, I'll call it B, within finding critical points, is to set our f prime of x equal to 0, because the derivative function gives you the slope, and the slope is going to be 0 at every critical point, because the critical point is just where the function changes from going in one direction to going in another direction. So if we set 2x equal to 0, we get x equal to 0 over 2, or x equal to 0. So we know that the point 0 is a critical point in this function, x squared. In this function, at point 0, there is either it's changing from negative to positive, or it's changing from positive to negative. I'm going to pretend I don't see this graph, but I know that this is one of the critical points, and this is the only critical point in this function. If you had a function that had more critical points, it wouldn't be as simple as x equals 0. You'd end up with x equals 0 and 2 and 3, or some other values as such. So once we find the critical points, then we need to know our endpoints, and our endpoints are -2 and 1. So now that we know this, we need to go back and plug in our endpoints and our critical points, in this case just 1 point, back into the original function, and the highest of the values that we get out of this will be our global maximum, or our absolute maximum, and the lowest of them is going to be our global minimum, or our absolute minimum. So let's go back and plug it in. Let's say if we had f of 0, that's our critical point. 0 squared is 0, so that's 0. F of -2, that's one of our endpoints. -2 squared is 4, positive 4, because two negatives multiplied by each other make a positive. And then f of 1, which is our other endpoint, is going to be 1, because 1 squared is just 1. The highest of these points is this one, and the lowest of these points is this one. And so you can go back to the graph, and you can see that this actually gave us the right answer. The lowest point is f of 0 equals 0, and 0 is the lowest point in this graph. Let me use a different color. 0 is the lowest point in this graph, and then f of -2 is 4, which is the highest value, so -2 is the highest point in this graph. And so we can use our knowledge of derivatives by following these steps to figure out, in any graph, the absolute maximum and the absolute minimum. If you have questions about this, please send me an email. and I'll try and answer your questions the best I can.